To see so many people to come and participate. Let me start by talking a little bit about IEEE. IEEE, there's 400,000 members worldwide. It's broken into 9 regions. We are region 3, and then each region is broken into sections, and we are the Eastern North Carolina section. And it takes basically the Raleigh RTP area out to the coast in North Carolina. And speaking today is from the Winston-Salem section. So their chair, Bill Williams, is in the back here. So you're welcome to talk to Bill and find out what's going on in Winston-Salem. Let's see. At the end of the table is Mary Ellen Randall. Mary Ellen is Director-elect for Region 3. So she'll be one of 9 directors in the world for IEEE. And it's quite a privilege to have her in our section here. So if you have any questions about IEEE, she also has membership information. If you're not a member and are interested, she can help get you set up and get you registered as a member of IEEE. Let's see. The Robotics and Automation chapter, of which this is part of, we meet the first Monday of every month. So you're always welcome to attend. In fact, you're welcome to attend any IEEE meetings. They're always open, and if there's one that you see that's interesting, you're welcome to attend. And if you're looking for the calendar, if you Google IEEE space ENCS, Eastern North Carolina section. So IEEE ENCS is the website, and the calendar is there. And if you see meetings that you want to attend, you're certainly welcome to do that. The exception, I just said we meet the first Monday of every month. Next month, September, the first Monday is Labor Day. So there will not be an RNA meeting in September. So, but watch the calendar for the October meeting. There is a meeting that's tentatively scheduled for October on the EV Challenge. And I know a lot of the people here are very interested in STEM and STEM activities. Between FIRST, I know there's a lot of Wake Robotics people here tonight. The EV Challenge is a program where high school students convert a standard gas automobile to an electric plug-in. And then they have a year-long program, and they do training on different concepts about the electronics and the batteries and safety, and they actually perform the conversion. And at the end of the school year, there's a big competition where the vehicles, although primarily from North Carolina, they come from as far away as Ohio, and I think they had a team from Iowa at one time. And they all come together to compete and do a series of challenges together. So that's a really exciting STEM program, so watch for that on the calendar as well. So I'm going to pass around the sign-in sheet. If you would mark whether you're a member or non-member, we try to keep track. Non-members are welcome, but we just try to keep track of how many of each. And we'll get that filled in, that paperwork. So, and I have a whole pile of books here on Servo magazine that someone has donated. I forget whoever. So, yeah, right there. Is it Jim?
Yes, that's
Jim. So anybody that wants to take any of these home, they're all available. So come take a look at them, take them home, and do with them what you want. So For those, the tower members that have joined us, I haven't done this the last couple meetings because I got sidetracked. But tonight, I'd like to go around the room and have everybody introduce themselves. It's not to put you on the spot, but a chance for people to know who you are, who you're affiliated with, whether it's at work, Wake Robotics, whether it's with a school. Just so everybody knows who everybody is. So I'm Grayson Randall. I'm chair of the Eastern North Carolina Section Robotics and Automation Chapter. I work for a company called Ascot Technologies. We do business apps that focus on mobile delivery of data. A lot of cell phone and tablet type apps. And move on.
Hi, I'm Daniel Parker. I'm an adjunct instructor at Forsyth Tech and also a lab assistant, part of the Forsyth Tech IEEE student club, and built this printer. It's on the desk here.
I'm Joe Guntner. I just graduated from Forsyth Tech with a diploma in computer integrated machining. I'm currently employed doing glasswork and not installing windows, making stuff out of glass. And yeah, I think that's about it.
My name is Bobby Garrett. I'm the president of the Student IEEE Club. I'm a recent graduate of Forsyth Tech in the Computer Engineering Technologies Department, and I will be starting back in the fall to get my Electronics Engineering Technologies degree, and hopefully on to UNC Charlotte after that. And currently I'm also employed by Marcus Parker in his glass studio.
Oh yeah, he's my boss sometimes.
Thank you again. I guess I'll turn it over to Bill. I want to say a couple words.
Yeah, I'll piggyback a little bit on Mary Ellen's talk. If you're a student, you can join IEEE for what, $35 a year. Is that right? 32 or 35 a year. It's very,
25, one of those.
it's very, very inexpensive to join as a student member, and that goes for graduate student members as well. We have a lot of our master's and PhD candidates at Wake Forest in the bioengineering program. They're student members, and they're only paying $35 a year. So thanks again for the invitation to be with you. We're glad to be here. These guys are our newest student club, in addition to the one at Wake Forest and Virginia Tech. I'd like to introduce Carol Perkins again. Carol's the founder of the student club at Forsyth Tech and adjunct professor there. Carol's been in electronics, what, 5-6 years, something like that. Is that right?
A few, yeah.
If you bought a digital watch, looked at an LCD, LED screen or something, Carol was probably involved as a principal manager in the product, in the development and promotion. But Carol's working now using his entrepreneurial skills to bring this to the forefront, teach kids. I heard somebody talking about somebody's involved in teaching robotics to first grade and up. Oh, that just blows my mind. That is wonderful. That is really, really cool. But I'll take this time to reintroduce these guys. Marcus Parker graduated from Forsyth Tech with 2 AAS degrees in computer engineering and electronic engineering. Now employed as an adjunct instructor and lab assistant. Also runs his own company called Upcycle Studios. He's also in the glass blowing business. So if you need any custom glassware, this is the guy for you to go to. Takes recycled glass containers and restructures them, recycles them, etc. And did you bring any of your really cool looking wine glasses that you made?
Did not. I've got some photos on my phone.
Oh, cool. And Bobby Garriott. Bobby is a newly elected president of the student club. Has a AAS degree in computer engineering and is employed at Forsyth Tech, working for his electronic engineering degree. He also works with Marcus. And then Joe Guntner works with Marcus as well. He's treasurer of the student club. So all three are working together with other members of the student club to bring this to the forefront, get other people involved in it. And I'd also like to mention in Winston-Salem, I don't know if it's the only one in North Carolina, but we have a dedicated STEM high school down in Winston-Salem. It's grades 9 through 12, and it's strictly STEM. And they're doing some really amazing things there. So I'll turn it over to you guys.
All right. So, start off with a little brief history here. we go. All right. What's going on here? Hold on one second. Technical difficulties. Beginning. All right. So how the club started. This past spring semester, Mr. Carol Perkins, an instructor in our electronic engineering department, began the student Forsyth Tech IEEE Club. It started with the primary goal of engaging students in exercises to, started with the primary goal of encouraging and engaging students to exercise the knowledge and skills learned in the classroom through various projects and activities. Through this, students could also become aware and participate with the local IEEE chapter and help promote our students, school, and the IEEE. The club has been initiated in the electronic and computer engineering department, but we've also attracted many students from other fields of study, including mechanical engineering, computer programming, and nanotechnology. Our mission statement is to provide hands-on experience for students from different programs through programs of study and projects that explore electrical engineering and other related disciplines. So for our first project, several ideas were proposed by members of the club. One of them was parallel processing, utilizing low-cost Raspberry Pi microcontrollers, a modular analog synthesizer, and a microcontroller-based automatic cat feeder. And then one member, Dawn, suggested that we construct an open-source RepRap 3D printer. So everyone was pretty enthusiastic with this idea. The whole concept of constructing a printer from scratch, essentially. So we put the automated cat feeder on the back burner and then set out and began researching the various models of 3D printers, the materials that are needed, and a lot of that information was all gained through reprap.org. They have their own wiki, and there's lots of forums, and a lot of the open source 3D printers are all up there with plans, the bill of materials, all that good information. So then at our next meeting, we had a guest speaker. He was a member from the local Winston-Salem Fab Locker hackerspace, and he brought in a RepRap printer to demo for the club. Everyone was really impressed with the performance and the accuracy of the parts that it was producing. So in this slide, these are prints that Austin from the Fab Locker did. You've got a 0.3 millimeter layer height squirrel, which is kind of medium to low resolution. Then a 0.2 millimeter layer height squirrel in the center, with a little bit nicer resolution, less banding on the z-axis horizontally. And then this one on the end is another 0.35, but it's been treated with acetone vapor, and it smooths out the ridges and gives it more of a plastic mold injected look. So then after some more research on the RepRap forums and discussions with other people at the hackerspace who had made their own printers, I was drawn to the machine and decided to build a variation on the Mendel Max design, which is this one here. And so quickly after researching, I found out that it was one of the more popular DIY choices in the 3D printing community for several reasons. It's got a pretty rigid A-frame construction. It's also got space for a little bit larger build area than the heat bed that I have here. Actually going to upgrade it to match about the size of this aluminum disc the heat plate's sitting on. Then also there's a lot of choices for components as far as if you want to use like low-end drill rod for your linear motion components, or if you want to go with like a higher-end rail and car system. This is from a company called PVC Linear, and it's got a nice smooth motion. It's coated with Freelon. It's like a chemical-resistant Teflon type material, and then ceramic coated rail, and there's very little play, hardly any play whatsoever. So as soon as I get back home, I'm going to tear this down and rebuild it with some new parts. Also, another member of our club, Edgar Salazar, he came upon this new extruded aluminum profile that's designed specifically for linear motion components, and it's known as MakerSlide. He used this to construct another open source design known as the OrdBot, and that's also gaining popularity on RepRap and other places as well. So how I went about constructing this, first off, went and talked with Austin, who had demoed his Mendel Max at the club, and talked to him about getting the parts that I needed, all the green parts here around the frame. Went and got the plastic, got that ordered, then had him print up all the parts. Then went back to the RepRap forums, got the bill of materials, and started getting the extrusions, the drill rod for the linear motion components, Acme threads, stepper motors, electronics, and some more filament to print with. And so through the efforts of Edgar and myself building our own printers, it also helped provide the club with benefits of knowing where to get parts at a good price and also at good quality. So some of the materials needed, or pretty much all the materials needed here. The aluminum extrusions, those were acquired from a company called Misumi. They've got an outlet here in the United States, so you don't have to get it shipped from China, so you can get it pretty quick. It's about $60 to $70 for the extrusions and the T-nut slots that you need, and depending on whether you want just plain aluminum or if you want to anodize, I think it's about a $5 difference. Then the stepper motors, they run about 15 a piece. You need 4 to 5 depending on what kind of extruder design you want to go with. Then you've got the hardware, the nuts, bolts, the drill rod for the linear motion here on the X, Y, and Z, the Acme threaded rods. Then the electronics, this is using an Arduino ramps setup. It's got an Arduino 2560 with the ramps 1.4 shield on top, and that was obtained through reprapdiscount.com. And also came with the heated bed, all the end stops, and then also the display and encoder. Then there's the hot end, which is like a glorified hot glue gun tip. It's got a heater element at the end and a nozzle. It's printing at 0.4 millimeter currently. All metal nozzle. There's no. Some people like the J-head has Teflon going through the inside, so it wants to max out. It'll max out at like 240 centigrade. So if you try and print things other than ABS or PLA, you can have troubles with that breaking down and melting and falling apart. So knowing that, I went with an all-metal design, and that's the Trinity Labs Magma extruder. And with that, it was about 60 bucks. And then the printed parts that I had Austin make, I think it was like 25 for the filament, and I think he charged me like 35 to print it. So depending on who you know, printed parts, it can vary. People sell kits on eBay for about 100, 120. Filament. The two main types of filament is ABS. It's got a higher melting point, around 230 degrees centigrade. That's what's printing right now. It produces really strong parts. It's really recommended for doing mechanical parts. This whole printer was made in ABS. And then you have PLA. It has a much lower melting temp at 170 centigrade. It produces prints which are a little bit more brittle, not really recommended for the parts of a printer. They're also susceptible to heat and they can warp easily. We had a friend that made a printer out of PLA and then set it in his trunk on his way to give a little demo, and when he got there, the whole thing had just kind of melted down into a blob. So learned from his mistake. So aside from ABS and PLA, we tried some other things. We have yet to try nylon, but there's a company, Tallman, that's making nylon in 2 different grades and in the 2 popular sizes of filament, 3mm and 1.75mm. And we have experimented with weed eater line, and we've had pretty good results with this one particular brand. These orange pieces here were printed with the weed eater line. The only thing is that we had to take it and place it in a kiln and cure it at 300 degrees Fahrenheit for approximately 3 hours, and that gets rid of any moisture that's been absorbed into the plastic. If you don't do that, when you go to print it out, the plastic just comes out as foamy mess. And then, so after it's been cured, we were able to run it through the printer and got some really good, strong parts, and also kind of has some flexibility to it without wanting to tear apart on the Z-axis layers, horizontal layers.
If I may ask, what type of plastic is weed eater line?
It can vary from manufacturer to manufacturer, as I've found out. We got some from like Walmart. They were like translucent, and the prints were extremely flexible. They had a lot of flexibility to them, but they wanted to warp and peel up off the bed. As they were printing up, after about 10 layers, the whole piece just started to curl up. So I found one particular brand, I can't remember the name offhand, but it stuck to the bed throughout the whole print. It's been doing really well, so I've kind of just been sticking with that at the moment. So then going through the software that's involved, software tool chain. First you have your CAD software, which is used to design and refine the 3D models that will be printed. Google SketchUp is pretty good introductory software. You have to add some plugins to make it work with the STL files that are popular. Blender is another open source program that has a lot more advanced features in it compared to SketchUp, and it's more geared towards advanced 3D modeling and also 3D digital animation. And there's Autodesk's 1.2.3D Beta, and that's another powerful 3D design tool, and it's also available for free like Blender. So once you've got your 3D model created, it can then be sent on to your CAM program, and the CAM software can be broken up into two programs actually. You'll have your slicer, which will generate the G-code, which is the same code that's used to run CNC mills, and in the 3D printing community it's known as slicing. So the program that we've come to use is called Slicer, and it's spelled with a 3 instead of an E. It's been the go-to choice for a lot of the people in the 3D printing community, and it does a good job of, basically what it does is it takes your 3D model and slices all the layers down and generates the tool path for the machine to run. So once it's been converted to G-code, then it gets ready to be sent to the printer, and the second part of the CAM process would be the printer interface. Pronterface was what we first tried out, and it worked really well, except there's one issue, and that's if you've got your computer running your printer, say something comes up like an automatic update for a program that you weren't expecting, or something hiccups on the PC, chances are it's going to hiccup on the print. So by using this built-in display and encoder wheel, and it's also got a built-in SD card reader thing, you can put the G-code file on the SD card, place that in the side of the control panel, and then operate everything independently, just all in the printer without having to have it connected to the PC. So that saved a lot of potential problems
Before you move on,
came around.
in the list of CAD programs might be interesting to people, there's a company called Tinkercad that was just bought by Autodesk, and it is an entry-level CADing program that's very, very accessible, particularly to young people. Has a lot of things pre-built in it. You need an alphabet letter. Somebody's already built an alphabet letter as a shape, and you can drop it in. It has some of the same things that you get with some of the more advanced CAD programs, where you can work both in 3D, or it doesn't have a lot of the 2D and then extrude. It has much more of the, you already have an object that's close to what you want and you can modify it.
Yeah, I've messed around with Tinkercad a little bit. That is, I agree, that's a really good introductory software, and it's all online and free.
At the moment.
At the
Keep your
moment,
fingers crossed.
but they have tied it in, you know, with what Baker bought, and they're trying to sell you a machine,
Yeah.
and they have a $99 fee now, you know, just for beginners. Keeper.
Oh, because we're still on free, so maybe our licenses are grandfathered in.
Maybe.
I believe that's what happened, because it was shut down for a minute, and then it got picked up by Autodesk and put back online.
Right. So then the other one I wanted to suggest is, I believe right now you can only run it on Linux and maybe Unix-based systems, but FreeCAD has a lot of look and feel of Autodesk. At least it's very similar to Autodesk Inventor in my experience. It isn't as stable as you'd like, but usually the work has been saved before it crashes, and it usually only crashes when you're undoing. But it is a no-cost alternative that gives you almost all the file formats you want. Its own format and STL and most of the other major, it'll export to most of the other major file formats. And it's under, people are really excited, so it's under heavy development, so in a short while it will be stable and nice. I've been using it and been able to model what I want without much problem.
Okay. Yeah, another program also is OpenSCAD, and it's more of a program based. If you're familiar with programming, you may like this CAD program. It allows you to do like parametric scaling things. So if you want to work on gears, mechanical parts, and you want to set your variables and change certain ones, it's really good for that.
There's also a gentleman in Spain that's extended it so you can use C++, so you can do object-oriented style
Right.
programming.
Right.
And FreeCAD is based on the same libraries that OpenSCAD is. The underlying stuff is the same. The question is, do you do it graphically or do you write a script? Is really the big difference between
Okay.
the two.
Okay.
And I'm sure that any software developer in the room would be welcome to help with either of those two projects.
That's good. All right. Jeff.
Well, that was Marcus.
All right.
I'm Joe. We'll get talking about more things. We're clicking on the bottom here, right?
You actually have to put that right there. This is your slide.
It goes. No, I'm going to go to the next slide next time. Not this slide. All right, so I'm going to upset the computer gods and move this thing over. Get less blue light in my eyes that way, perhaps. So this past June, we all got together and went to Maker Faire as the Forsyth Tech IEEE Club. And that was a lot of fun because we just wanted to show off the printers that our members had made and show off the frame we had built as a club. And we also had some time to hand out a bunch of IEEE literature while we were there too. So the whole sign wouldn't fit on the table. We folded it. By the time everybody took books and pens, you could see IEEE across the top. And so yeah, we ended up going there, having a lot of fun out, here in Raleigh. That's it, out in Raleigh. But we built or printed a bunch of little MakerBot robots, maybe 1.25 inches tall or something. And we thought we'd offer them for like $1, say we're trying to get money together, finish the printer. $1 sounds good. So we got through and counted at the end, and we got like $250. So we're still not there yet, but it looks like the world likes us about 2.5 times more than we like each other. So that was good news. So we ended up going through this, trying to figure out how to do a desktop printer. We had to look a lot at the actual industry printers out and what's being developed and how things are trying to go. So we've found out there's not just the little plastic fast prototyping. There are machines trying to run cement, and there are machines printing metal and also biomedical printers that can go either cells squeezed out or they can form a structure for cells to grow on. So there's a lot of neat stuff out there. You've got a picture here trying to build up a house, and those are a bunch of Stratasys printers all in a row. I'm not sure what they're producing, but they are. So the company Stratasys, though, they're pretty much the biggest player right now. And they've been that way partly by acquiring a few second biggest players and whatnot. So one of their first was Objet, based out of Israel. And Objet was one of the first to do a multi-material printer, so they got snapped up real fast. But they could do, aside from different colors all in one print, you'd also get softer rubber-type compounds. They do transparent and opaque compounds. And they would also do support materials that could just be washed away with water and such. So that was a big one. They snapped that up. And most recently, they picked up MakerBot and Thingiverse.com. And MakerBot had previously been doing, they still are, they're doing the tabletop
home hobbyist type printers. But Thingiverse.com is a giant repository of tons and tons of STL files, lots of people making something they want to build, and they post it up there for other people. And you'll see a bunch of files that are slight differentiations of it that fit somebody else's design better. And so they ended up with a lot of publicity and effectively a free R&D department too, so that's pretty neat. And they're working to get 3D printers going on actual construction now. There's been one guy in, I guess it's Holland or Belgium. They're right next to each other, or the same thing. They've been going through, and guys out there have been working to design modular sections for a house that could be 3D printed on a concrete 3D done. The one going on in the US is Contour Crafting, and it's the name of their company, but it's also the name they've given to their system where they just build walls and don't have to deal with any horizontal planes or support. And they're trying to make buildings through this, so they've gotten as far as a smaller model, but things are working. They just need to put it on a giant scaffold and do more than just a vase or walls. So we've also got 3D printed metal, and this is one thing that intrigued me a lot. You can do either metal sintering, which is a process where you've got metal either just a powder or in a medium that'll hold it together. And it gets fused but not fully melted together to full strength. So it's a process where once you have your part, you'll need to do a further heat treat or something to get it up to full strength and a solid consistency. Some of the methods for that still have problems with developing voids in the print because the metal isn't evenly distributed through the medium. So the really neat one is selective laser or electron beam melting. They're the two varieties. They both go on in a near complete vacuum, and they melt the metal to the point where it's full hardness, basically solid chunk of metal. You're done, and it's already been heat treated, stress relieved, all that fun stuff, and it's just finished part. And there are also going to be some interesting things going on with 3D printing for extraterrestrial exploration as well, because you know, it's hard enough to build things in space, but before we even get to making buildings, we're going to have astronauts running into different problems where they will need tools and production facilities, and you don't want to go hauling a whole factory into space. So 3D printers will come out great for just tooling to begin with, and then once we've got it to the point where you can just put one up and start setting the building up, that'll run much better. So now I'm going to turn it over to Bobby as he gets on with the medical part.
Hey, how you guys doing? Might be a little nervous. Public speaking isn't really my forte. I'm much more comfortable with a soldering iron in my hand. 3D printing is changing the medical industry. There's a lot of things we thought were impossible that are becoming a reality with 3D printing technology, such as 3D printed organs. We believe that 3D printing could be a more practical and cost-effective alternative to transplants and cloning. In fact, right here in North Carolina, Dr. Anthony Atala, the director of North Carolina's Wake Forest Institute of Regenerative Medicine, is making this happen. At a recent TED Talk, he printed a prototype human kidney live on stage using living cells. Although a fully functioning kidney for transplant is many years away, Atala's primitive organs were able to produce a urine-like substance. This is an amazing breakthrough that we feel could potentially save a lot of lives. But the cool thing, though, is the fundamentals of printing an organ really aren't that much different than the methods used for a desktop 3D printer. Like other forms of 3D printing, the living tissue is printed layer by layer. First, a layer of cells is laid down by the printer, followed by a hydrogel that operates as a scaffolding material, which that process really isn't much different than the support material needed to support contours and curves with the ABS plastic so the parts don't collapse. And this process repeats with the living cells, and then the cells fuse and the hydrogel is removed to to create a piece of material made entirely of human cells. Which after the part's made or the organ is made, then they're moved to a bioreactor where the tissues continue to grow as they would in nature and form a fully functional human organ. Also, there were some doctors at the University of Michigan that were able to apply for an emergency clearance from the FDA to make a tracheal splint for an infant boy. Without the splint, doctors claimed his death would be imminent. The 3D printed splint was sewn in such a way that it would expand the collapsed bronchus and give it the support needed to grow properly and strong. The tracheal splint was printed with a biopolymer called polycaprolactone, which is absorbed into the body over a period of 3 years, which after that time, his bronchus should be strong enough to support itself. But splints are just the tip of the iceberg when it comes to 3D printed implants. 3D printed bones are a possibility as well now. Researchers in Belgium have discovered bone replacement surgery using 3D printers. These printers use a laser, much as the way Joe described earlier, to form a replacement bone made from titanium powder. The main advantage to using titanium is zero risk of infection and rejection by the patient, while the 3D printer gives us the advantage of a perfect fit. In the past, these sorts of implants were limited to a handful of sizes that the patient had to make do with, but with 3D printers, it's possible to reproduce the patient's original bone structure. Universities and hospitals aren't the only place where 3D printing is lending a helping hand, though. We have a project called RoboHand. RoboHand began when Richard Van Ass lost 4 fingers on his right hand in an accident. He decided he wanted a mechanical hand to give him functionality back. He got in contact with Ivan Owen, who was a props and puppeteer maker for the movie industry, and invited him to collaborate on the design. They used a MakerBot replicator to begin prototyping sets of mechanical fingers. Their design worked out really well, and they got the idea that they could use this alongside with 3D printing to make low-cost but functional prosthetics to help children with a disease known as amniotic band syndrome. They decided to keep their design open source and put it up on Thingiverse so that anyone with a 3D printer could get involved with the project. The IEEE Club right now is in the process of printing a hand for a 6-year-old boy right here in Durham. We believe this is one of the most practical uses we've seen for a 3D printer, as a RoboHand can be made for around $50 instead of the thousands that a prosthetic from the medical industry can cost. We discovered the RoboHand project during a brainstorming session after the Maker Faire. We wanted to find a practical use for desktop 3D printing after hearing a lot of comments at Maker Faire. A lot of people walked by and said, "Hey, this is neat, but what can you really do with this?" And Marcus had read about RoboHand and shared it with the other club members. We thought it was a perfect project to show what could be done with do-it-yourself 3D printing, and anyone with a 3D printer can get involved with RoboHand and get connected with a person who needs one through their website. Do-it-yourself 3D printing has been a great way to pique the curiosity of students and inspire the next generation of engineers. Projects like RoboHand are a great way to attract new students to the IEEE Club in 3D printing. We feel that students that might not normally be interested in electronics and an electronics club might want to join the club and get involved with a project like RoboHand. And speaking of inspiration, 4 students from our local IEEE Club have decided to form a business with 3D printing. These students have been working together to design their own line of 3D printers to sell commercially. They have plans for 3 printers, a low-cost, a mid-range, and a high-end printer. The low-cost printer is using mostly 3D printed parts. The system that Marcus is coming up with using PLA bushings and ABS brackets to hold the extruder to replace, some of the more expensive parts like the Delrin bearings and things like that. And also on our high end, we also plan to use the Freelon and ceramic car system. Basically, we want to build a better mousetrap. What engineer hasn't looked at something and said, "Hey, this is cool, but I think I can make this better." Students also have plans to design their own electronics. and software instead of using the open source stuff that's available. The goal being to streamline the toolchain into a single, easy-to-use, intuitive application. We have hopes that we can inspire other IEEE Club members to get excited about engineering and possibly become entrepreneurs themselves. We hope to pick up momentum with our IEEE Club on campus. We feel like the 3D printer is a good lure to attract students to the club. We'd like to get more students excited about hands-on engineering projects. And we have a few new ideas we're kicking around for next semester. One of the ideas we're kicking around is analog synthesizers. Marcus and I are both really into electronic music and analog synthesizers, and we feel like it's a great way to get people some really good hands-on soldering skill and teach them about op-amps and oscillators and other such circuits. Another idea we're kicking around is parallel processing with Raspberry Pis. These low-cost boards have been gaining popularity and spawned a whole new niche in computing. Not to mention, they're just a whole lot of fun to play with. Well, that's about all we have for you guys right now. We'd really like to thank you guys for letting us share our experiences and our knowledge we've gained on 3D printing through the IEEE Club and our education in the EET and CET departments at Forsyth Tech. And we would like to open up the floor for questions now at this point.
So I have a question. So what was the biggest hurdle that you had to overcome to get this all functioning?
That's a good question.
Money.
Money.
Yeah, money.
Money, raising the money. 'Cause, it's a student club and we're all, raising the money ourselves.
As much time and fiddling and thinking as it takes, I don't know what the cost of that is.
And time as well too, because a lot of us are continuing education adult students. I'm 35 and was working full time with while taking 17 credit hours and participating in IEEE Club. So time and money were pretty much our biggest hurdles.
From the time that you had built it, you had the frame, you put it on, you turn it on and it moves and stuff comes out, oozy out. Some time where you could reliably print a part that looked like the drawing you started from, which is a whole nother level of success. Right?
Lots of calibration.
How much time do you think you guys put in to make that transition from it oozes out, oh look it moves, yay, to look I have parts?
Marcus?
We cheated.
2 days.
2 days, 2 solid days?
Yeah. Not even 2 solid days.
No.
We had a lot of help from Fab Locker, guys at Hackerspace there in Winston. Several of the guys there had a Mendel Max style printer, and a lot of the settings, all the steps per unit were pretty close. And then there's also a RepRap calculator that was set up by Joseph Prusa, and you can go in and put in what steppers you're using as far as the degrees per step, if you're going to be micro stepping, at what fraction, and then the number of teeth and pitch of the timing belt that you're using. Plug all that in and it spits out what your steps per unit should be. And I tested those against what the Hackerspace configuration files had, and surprisingly it was a little bit more accurate using that calculator. And then with the extruder, I think for the X, Y, and Z, that was pretty easy to get set up, just running some calibration tests, and then going back and testing all the dimensions and everything. But as far as the extruder, that was one part that was just kind of shot in the dark, hoping to hit it on the
A lot
head.
of trial and error with the extruders.
I think it took about like 6 or 7 little calibration cubes before everything was measuring out pretty spot on and getting nice solid prints. Then playing with the temperature settings to avoid warping on larger prints. It took more time. It would go up to like 4 or 5 hours, things like that. You start having issues. So adding the heat sinks and the fans on the stepper motors helped eliminate a lot of missteps.
So your stepper motors have heat sinks on them?
Yeah,
Yes.
we put some old CPU heat sinks and fans on the
So you're
steppers.
running pretty hot then.
Keep them
you're
cool.
running quite a bit of current through them.
Not necessarily. It's just if it sets up to go for say like a 6-hour print, over time. Even now that summer's kicked in, I noticed that it operates a little differently. I've had to go through and step the current, or adjust the current on the steppers. Kind of got it all tweaked out, and it's working good, so. Yes.
So the software that you have running the microcontroller, did you guys write that, or is that something that?
It's another open source piece of software. It's the Marlin firmware. It gets put onto the Arduino board. Then Slicer to generate the G code for the files to print. I found those two work the best. And then having spending the extra, I think $40-50 to get the control panel with the built-in SD card reader and the encoder makes a world of a difference, as opposed to having it connected by USB to the laptop or desktop system. Yes.
If the average person wanted to build a printer, what skills do they need to be successful?
Soldering, some mechanical, just general mechanical skills. As far as the Mendel Max goes, there's a lot of guides and how-tos as far as getting the frame and some of the electronics put together. Then when it gets into the calibration of it, that's where a lot of people kind of stop putting information up on the web. I think a few people have completed that information. At the time that this was getting put together, there were tons of videos on YouTube that would get you all the way up to having the frame, steppers mounted, belts put on, and then when it got time to do like your test print, calibration, and just calibrating the frame and everything, it just kind of dropped off right there. So that's when I went and consulted with fellow tinkers over at the Hackerspace and got some insight and knowledge there. And then a lot of trial and error, just kind of putting our heads together if we came up with something that didn't look right or was giving issues.
A lot of it also is how raw materials you want to start with, because you can order pre-cut extrusions in kits, and they're what, like $60-70 for the kit. But
Yeah.
if you happen to have a machinist around, you can order a large length for about $33.
It's like, yeah, I think that's what
Cut
it is.
and mill the
That makes
ends
a
and
lot.
do it yourself and save a lot of money that way.
So you can use a hacksaw and a file and a tri-square if you want to. It's cheaper than a mill.
Yeah, it's a lot cheaper than a mill.
A little more labor intensive, but
A little
same
more
results.
labor intensive for sure.
It's a project. You can't do it too fast.
So, what are you printing now? I'm curious.
It's a scan that I took of my fiance with the Xbox Connect, and then some open source software. ScanX is the name of it. And so yeah, it's printing up from like the waist up right now. And then the stuff there's support material in the front and in the back to kind of support the chin. So when it gets up to the level of the chin, it's not just, spitting out plastic in the free space. So there's scaffolding all around to help support the chin and sides of the head, back of the head and everything. And all that peels off really easily once it's printed up. It's like barely even connected, like touches in like a few points around the print, and you just get your fingers in there and just pull it off.
I need to
Sweep,
know
essentially.
if you had the same experience. My 14-year-old son used the same software, the same scanner to scan me, and they made a really alarming discovery, and I'm wondering if it went the same way for you and your fiance. His scanner ended right about here, the chair he put me in, he didn't aim it just so it caught my whole head. And I discovered my whole head is hollow inside.
Yeah, I found that. So it's like I set up the Connect on a tripod and kind of have it up and down an angle, then have the person just like go around in 360 degrees. And then I'd take the tripod and the Connect, and I'd kind of like get the top of their head. And on the software, it's really cool to like show where the Connect is in relationship to the object that you're scanning. And when I go to do that part at the end, it's like it's got a little trail of where it went around the person, and then that little like dip up to capture the top part, and it gets all that data and processes it into a cloud point mesh topology. Is that
right?
Yeah, that's
So you're saying he did it to me on purpose? He put that in my head.
So yeah, after you do the scan, if you kind of like tilt it up and hit the top of the head, it'll fill in those voids. And then doing like when you go to render the image or work on the model, running like the watertight feature, it'll go through and fill up any voids or holes, and essentially would have given you a flat top.
So that's where your brains come from.
So you could go ahead and do a vapor bath on it, make it nice and smooth, and tell everyone that you intended to have a shot glass.
Part of his comment, I was going to add on saying, you're very scary to print. Either you get it right or you got an argument. Good luck.
Yes?
I was going to mention that a few years ago, IEEE is a huge organization, like Grayson mentioned. They have an educational activities board. They also have a Women in Engineering Committee, and the Women in Engineering Committee often look at what things encourage women to go into engineering and things like that, and what influencers don't. And the Educational Activities Board and Women in Engineering got together, did some research, and found that women are less likely to go into engineering than they are to like law or medicine, because they don't see the direct connection, assistance, or what they're doing to influence society. So I think your RoboHand example is spot on. You're going to pull a lot of people in. And the other thing, what they did once they learned that, is they set up some undergraduate coursework that helped to show more examples of how engineers influence society. And what they found was they drew more women in, but they also drew more men in. So I think that I commend you on, coming up with something like that. That's such a good, makes it understandable to everybody as to
Accessible.
how important this is.
And we would like to see the engineering field be a little more balanced that way. And we do think it's pretty cool. Our one female member of our local IEEE club was actually the one who suggested the RepRap printer initially.
Do you guys have any experience with parallel computing?
I don't personally.
So when you gues come up with a project like this, you go in there with no prior experience, no understanding. So that's what you did with this 3D print.
Yeah, we just
Dive on in.
get together, brainstorm, decide which idea sounds cool, and go do the research, get the stuff, and have at it. That's pretty much our whole goal with the IEEE Club. Is we want to get people excited about engineering. We want to get students excited about engineering. So we feel the best way to do it is, sit down, vote on a project that everybody's excited about. We had a whole dry erase board full of ideas before we finally settled on the 3D printing.
Yeah, I wasn't there for that. They had to decide on a 3D printer before I would join.
Yeah, the 3D printer did draw a lot of people. Like after we had the 3D printing idea, it was only a few more club meetings, and we had people starting to show up from the Mechanical Engineering Technologies program. We had a couple of nanotech students show up and get really interested, and machining students.
The experience builds everybody's resume, right? Everybody who's involved now has a much stronger resume as well.
It's funny too, we're working on a Puppy Linux build for 3D printing, where we're trying to get all the software you need into a Puppy Linux build. We both have degrees in computer engineering technology, but ironically it's our machinist who is our Linux expert.
I'm not an expert, I'm just better than these guys.
You know what an expert is, right? An X in algebra is an unknown. Expert in hydraulic physics is a drip under pressure. So an expert's an unknown drip under pressure.
All right. We don't have enough pressure for that one yet. We'll see.
Are there any more questions? Well, I want to thank tonight. I want to thank everybody for coming and participating. Remember, we've got a bunch of magazines here. You're welcome to take them. And is there any pizza left?
Yes.
Yeah, there is some.
There's a lot of pizza left, I think, and it's going to get thrown out. So take take whole sheets of it if you want. So don't throw it away. Take the pizza. Wake Robotics has brought one of their printers, and I'm sure they'd love to show it off in the back. And I'm sure that we'll take more questions in the front. One more?
Yeah, I just wanted to add, Dr. Atala, who you saw on the program there at Wake Forest, his first big famous project, he's a urologist and a urologic surgeon. And he had a patient, a young boy, who was in a terrible accident and had completely torn his bladder, almost completely lost the bladder. He literally grew a new bladder using that kid's stem cells and then planted it into the child. And one of his cell printers was configured by one of our IEEE members in the Winston-Salem section. He took an HP inkjet printer, which now prints out cells. So if he wants to print a nose or an ear or whatever, he can use that printer. The printer really quick. And a friend of mine, they mentioned Brussels, Belgium, he had another company called Materialize. In Brussels, one of the biggest problems an orthopedic surgeon has is having to do a second operation. They do a hip replacement or a bone replacement or whatever, and sometimes it just doesn't work out. They have to come back and do a second. Materialize now can take raw data from an MRI and a CT scan, send it to Materialize, the hospital sends it to Materialize, they take all that raw data, put it into their 3D printer, and print out whatever anatomic piece they need, whether it's a bone or a joint or whatever. They FedEx it overnight to the surgeon, to the orthopedic surgeon. He can sit there and play with it in his office, look at all kinds of different approaches, and he only has to implant it one time, and it doesn't have to do it with people. So the applications for medicine are just amazing.
Okay, that concludes our meeting for tonight, so thanks again for coming.